All right, welcome back. So I've made a new snippet. Otherwise, basically doing everything the same. I have my same code. You can get that from the slides. A couple videos ago I talked about this if you want to follow with the same graph. So I'll start by defining breadth first down here, which takes a start vertex. Just call it start. And then we need to define a couple of variables. So I'm going to make my Q as an empty array, and I'm just going to add start in right out of the gate. We need to make our result. We could just copy this from up top, any of these, if you watched the previous videos. And my variable visited to keep track of what we've been to. Then we're going to loop while the queue has a length. And the first thing that we do is remove the first node in the queue from the beginning. So instead of pop, we're going to do shift. So queue.shift and store it in a variable. And we could define the variable here. I'm going to call it current vertex, just like we did in the last video. But I'm actually not going to redefine it in a loop. I'm going to move it up here and then set it here. So initialize it once, set it over and over, update it. Okay. And then we're going to visit that node, which means result.push current vertex. So we take the first item out and then we push it into our array that we return at the end. Now, the slightly trickier part, we need to go to all of its neighbors. So that's a this.adjacency list of current vertex. And then for each neighbor. What are we going to do? Well, we're going to check if it's been visited. Or actually, we're going to check if it's not been visited. That's what we care about. Because if it hasn't been visited, then we need to mark it as visited. Just set it to true. And we need to push it onto the queue. And we're actually done. So at the end, we do need to return it. So kind of a lie, we're not quite done. But now we are. So the way that this one works, if we step through it before we even run it, here's our sort of visited result that we're going to have at the very end. And then here's our queue. Let's do it like this. Okay? Perfect. We start by adding A to the queue, and then we remove it first thing and add it to result. And then we go to its neighbors, this.adjacency list of A for each. So there's two things in that list. There's B and there's C. And we're taking the first thing. If we actually looked at the list, B does come before C because I added that connection first. So we're going to add B into our queue, and we're also going to add C into the queue. And then the loop starts over, and we take from the beginning, we shift. So we remove B, and we add it here, if I can type. And then we add its neighbors. So we loop through. Its neighbors are A and D. Well, A has already been visited, so we ignore it. So we add D to the end, right here. And then we remove from the beginning, which gives us C. So we add C into the result, and now we go to its neighbors. Well, we've already been to A, so now we have to go to E. So we add E after D in the queue. Remember, first in is a first out. So we take D out, and we visit D. And we go to D's neighbors. Well, we've already been to B, so we don't add that in. We've already been to E. Well, it's in the queue at least, and that's when we mark it. Remember, we added in after we mark it visited. Okay, so then all we have left is F. So we add F, and now we go to E. We take that from the beginning with shift. We put it here, and then we're going to go to its neighbors. Well, we've been to all of them, so we don't actually add anything in. And we remove F finally, and that's what we visit last. Now, let's see if I'm just making that entire thing up or if this actually works. I'm going to comment that out, run our code, and we have graph.breadth first, starting from A. A, B, C. Oh, looks like we have a little issue here. Let's see. Aha, I found the problem. Maybe you saw this before me, but what we're not doing here is marking A as visited at the beginning, which actually is in my pseudocode, and I ignored it. You can see here, mark the starting vertex as visited. So what's happening there, if we just print out, let's do it at the beginning here, console.log the queue, and run my code, g.breadth first from A. Oh, I didn't have to rerun it. Okay, here we go. We start with A in there, but I don't mark it as visited in my visited object. So then we go take it out, we add it to our result, we add the children or the neighbors, B and C. Then we take B, but B actually has two neighbors, right? A and D. But we didn't mark A as visited the first time. So we add it back in, and then we add D. And then we keep going from there. But that's not right because we started at A. So if we mark it visited, you'll see at the very end we have A in there twice. That's not good. So we mark it visited right up here. We'll just do visited of start equals true. Perfect. You could also just set that here, visited with a D. And now if we keep that console.log, rerun the code, we end up with A, B, C, D, E, F at the very end because A never gets added back in. And it's all working. All right, so let's get rid of that console.log. Here we go. One more time, g.breadth first search of A, B, C, D, E, F, which means we're going A to B to C to D to E to F. That's breadth first. Okay, so we're going sort of left to right. You can think of it, whatever order they are in, the edges are in the adjacency list. We're going from the beginning of the list to the end. So I added A, B before AC. So we visit B before C, and then D before E, and then F. You could change it if you really wanted to. There's no easy, as far as I know, there's no shortcut to reverse for each. Some languages you can, just specify, I want to loop over this array backwards. But a sort of easy way, just to show you, if we do this, slice.reverse, and I run the code now, you'll see we start from A, but now we go to C and then B, and then E, and then D, and then F. So rather than A, B, C, like left to right, we're going right to left. Still breadth first. Just like with depth first, we had different orders. Same thing here. And I want to be clear, there's not only two orders. This could be a much larger graph, and we could have, 5 neighbors for A, in which case it's not just B, C, or CB. There would be 3 other neighbors to worry about. Okay, so that's breadth first. Hopefully you can see it's very similar to what we did with the depth first iterative solution. So now that we have all of this out of the way, we're able to visit every single vertex in a graph. We get to go to the fun stuff, which has to do with mainly shortest path algorithms. This is a really important thing to be able to do with graphs, and one of the most commonly done things in all sorts of applications, whether we're talking about Uber, or we're talking about Google Maps, or we're talking about Google search results. It's not just map stuff and GPS. So we'll talk about that in just a bit.